Hello, everyone, and welcome to the March session of Dr. Spotfire. This is our third session of the year, and it's held the third Tuesday of every month at 9 Pacific, 11 Central, or noon at the East Coast time. I'm here with Adam Faskowitz, and today we're going to talk about advanced custom expressions. But before we dig in, I want to welcome Adam. Adam, do you want to say hello to our audience?
Yeah, thank you. Really happy to be here. Excited to show some cool uses of custom expressions. They're very powerful, so happy to talk about it.
Excellent, thank you. So before we get started, I want to give you a just reminder of our slogan here at Dr. Spotfire, that learning is not driven by answers, but by questions. So keep the questions coming, not only during this live session, but also offline. This is key in learning because when we focus only on finding the right answer, we simply trying to memorize information or recall something that we have previously learned. However, when we ask the questions, we actively engage our minds in the process of exploring and discovering new information. So in summary, the process of learning is not just about getting the right answer, but about asking the right questions and actively engaging in the process of exploration and discovery. This session is recorded live via LinkedIn, Twitter, and YouTube. If you find it hard to read the screen on LinkedIn, just try to switch to YouTube. Maybe you get better quality there, and if not, you can always watch this video later. So don't forget to like and subscribe. And I have a very important announcement to make because I just want to share great news. We have a new data scientist in our team. Her name is Ada, and her name is named after Ada Lovelace. She was an English mathematician and writer. Also, she was considered to be by many the world's first computer programmer. Well, Ada Kanungo is the youngest data scientist here at TIBCO with only 13 days old. Neil, congratulations again. And on behalf of our audience, let's celebrate life every day. Okay, so let me go through the contents of what we're going to be discussing today. We have an overview of custom expressions, the type of custom expression that we have, calculated columns, aggregated functions, property controls, the syntax. This is just a very general overview just to have everyone on the same page. And we're going to finalize with real life examples with Adam that is going to explain more about these advanced custom expression. I'm going to go through some other ones. So what are custom expressions? So custom expressions are user-defined calculations created in Spotfire to allow analysts to create new variables or columns based on existing data and perform complex calculations that are not available through standard Spotfire functions. So let me show you real quick how they look like. So I'm going to, well, I have a bunch of examples I want to go through. But a custom expression, if you write here, expression dialog, you will see this dialog everywhere. Everywhere you can find this dialog for custom expressions. You can find it in the selectors, when creating a new calculated column, when doing some transformations on your data canvas, when you are setting data on demand. You can also do custom expressions when you're adding curves into your analysis, or if you want to do a tooltip that requires certain custom expression, you can do all of that. And I'm also going to show you how to create custom expression functions. So maybe you want to have a specific function written in R that you want to use to your expression. So that's going to be very, very powerful. Okay, let's go back to the slides so I can keep talking about this. Let me close this out, and there we go. So the types of custom expressions, I can define them by transformation expression that allows you to modify data value. For example, when you're creating or modifying columns or performing math operations, string operations, date type calculation, and other types. So if you want to calculate the revenue, for example, by multiplying the price of the product by the quantity of the product sold, then you can create a new column. Those are transformation expressions. Then you have the aggregation expression that allow you to summarize data, and then you have also visual expressions. These visual expressions are more used in the visualization level. For example, this one, I can have my color selector to change the color by the line amount or sales or some value. I can put it high or low, and then I can color my visualization, my bar chart, my scatter plot with different colors. And you can, and there's also navigation expression. I haven't listed this here because it requires a little bit more, and this is all also around the visualization expressions, where you have the over functions and the nest and the navigate period, and we're going to look more about that in a minute. Little bit of syntax just for everyone. There's a great video on the Spotfire Enablement Hub by Neil that covers in great detail a good introduction on custom expression. This is just a quick overview for anyone to be on the same page, because we're going to use some of this syntax along. But for this presentation, we'll just do some live interactions that will apply this. So the brackets refer to a column. We have here the sales. Then you have double / for comments. This can allow you to put comments in your expression. Then you surround this with the $sign, and you can put your document property. Then you can refer to a document property value. You can also use angles when it comes to categorical and hierarchical columns. Sometimes it's automatic. Spotfire knows that you're dealing with a categorical axis, but sometimes you get some error because it's expecting those brackets, and well, spaces and new lines are ignored, so sometimes it doesn't really format the indentations and whatnot. So let's get started with some of these use cases and examples that we're going to go through. We're going to go through the rank, percentile, TERR functions, then the node navigations, a general concepts about node navigations, and then we are going to hand it over to Adam so he can go on with the rest of the presentation. So let's look at the ranking functions. And please, if you have any questions, just send it to the chat. We'll be monitoring the comments, and feel free to ask questions as we go. So the rank function. Suppose you have a table with a column called sales, and you want to rank the sales value in descending order. So the rank and dense rank functions in typical Spotfire work in the same way as their counterpart in SQL. If you're familiar with SQL, it's very much alike. It's just a minor difference in syntax and usage. So notice that the rank function has two rows values of 300. We have the 300 here, and then we start ranking 1, 2, 3, and then because it's the same value, it gives the same value here, also 3, and then skips to 5. That's because the rank is ranking each one of them in consecutive order. And then you have the range which it doesn't skip. You have 1, 2, 3, again 3, and then 4. It didn't skip the 5, but it's kind of skipping those numbers and shrinking it down. Now you might ask, okay, well, what if I want to have 1, 2, 3, 4, 5? Sometimes that's very useful for certain custom expressions. And the answer for that is with this third option parameter that is called ties method. And you say, okay, the first one, then you will have 1, 2, 3, 4, and 5. Let's look at that real quick. And that's how it looks like in real life example. But I think you got the idea just by looking at the slide. And one thing that is important to mention here is, here I have a calculated column that has this expression, right? These two expressions. But here on the visualization, I need to have an aggregation. So if I look at my custom expression, I'm going to make this a little bit bigger. You see these brackets that I showed you at the beginning. It's because it's indicating that it's a categorical, and you need to have, well, I also have the nest because I want to have a name and then the rank next to it. So I use the nest function, and then I have the rank right there next to it. And the same is with the other one. Okay, let's jump to the next function, which is the percentile. Let me go back to my presentation so you can see. So this is the percentile, and it's just a measure at which that percentage of the total values are in the same as or below that measure. For example, 90% of the data in this example lies below the 19th percentile, whereas 10% of the data values lie below the 10th percentile. And there you can set the parameters. In this case, you have the x-axis, and then you have the number of the percentile number here in this represent the 10%. So how I can recreate this? Well, I have a Gaussian distribution here in my example for the percentile. And what I created here is two reference lines, three vertical reference lines that uses the percentage. Let's look at that further. I go to my lines and curves, and then I see that I can edit my custom expression, and I see that exact same, in this case is 50%, is drawing the line right in the middle of my distribution. And the other part that is worth mentioning is the coloring. So I wanted to color only the first, I think this is 30%, yeah, 30%. So I go to my colors. What I did here is I'm using the x-axis, and then I am getting the segments, and I have this color, the first one, I have a percentile here function, it's a built-in function percentile, and I put the value 30. So from the lowest value to the minimum value, this is the minimum value, all the way to the percentile, I have this on a different color. All right, now let's talk about the TERR functions. And I promised I was going to tell you about how to create your own custom expressions, or how to use R in custom expressions. So this is how to. Let me go back to my slide in case I miss anything. So here we have the example, and the TERR function, you can find it in the functions. Let me go through the custom expression real quick so you can see where you can find this function. Let's go back and then let's go to this. Well, let's go to this one so I can real quick go to the custom expression dialog. And I hope you see it. But here you have the function. So if I go to my statistical functions, I'm going to see a bunch of TERR functions. And here you have the explanation of each one of them and a couple of examples, how it works and everything. But basically, in this case, you have a string and you have to have some kind of output. This is hard-coded. You have to have the output and then the input and then some kind of calculation and then input column, which is going to be or input parameter. So let's go back and look at this in detail. And then I'm going to show you how this is going to be, how we can add a custom expression on here. So let's go back to my presentation. And so here is the TERR is going to return a real value. And this example is converting from Celsius to Fahrenheit. So I have this. I have to put the output. Oops, I have to put the output, and then the R is applying this calculation from my input, which is Celsius. For each value is going to do the math calculation. This is a real basic example, but that's how it works. And then you have other type of TERR functions that are aggregations. So the suffix can be real, Boolean, string, and different other data types. But this is the same thing. The only difference is this one returns an aggregated value. In this case, it's a median from the two inputs that we are adding here, input 1, input 2, and you can have as many inputs as you want. You just have to call them 1, 2, 3, 4, 5 in consecutive order. Then this is the syntax for you to create a custom expression or custom expression function, or how to create a custom. I'm going to show you how to do this real quick. But this is a syntax. The syntax is R. So I have a comment here, and then I'm using a package. In this case, it's stringer. And this function, what it does is you take a parameter, a sentence, and will camel case. Camel case is that it means that every word in the sentence is going to be uppercase, and takes the parameter. And here it's the same concept. You have to have one input. If you have more inputs, then you have input 1, 2, 3, and 4, just like we did with the aggregation example. And then you have to have some kind of output. So in this case, is calling this proper function is as the parameter is the input, and is excuse me, and is performing this calculation, is performing the string to title function with my string, and this is returning the title case string, and that's going to be the output. That's how it works. Let me show you where is that located and some examples. This is the example that that converts. This is using the TERR function, Fahrenheit to Celsius. Yes. Okay, so if I go to my calculated column properties, and I go to this one, look at this function. This is how I implemented, just like the example. But the one I want to I'm sure you get the idea of these two examples using the TERR. But the one I really want you to know is this one, the camel case. So here, look at the sorry, let's go back to the column expressions, column properties. Let's go back to this and look that I am using a camel function. That camel function is not going to be available in your Spotfire instance, because I created it's a custom expression and I put it under the conversion functions, where is here, and then I called it, or string function. I don't know if it's string function or column color, but I can always search for it. I think it was a string functions, text function right here. Yeah, here, camel. So I have my custom thing doing here, and we have the this example, and that's how it works. Where is this located? Very easy, very straightforward. I go to my data function properties, and then I go to my expression functions tab. I have two functions here. I have the TERR function and the camel function. Let's go to the simple one very quickly. And this is just almost like the string that I passed to the TERR function to begin with. And here, let me look nice. But basically,
Jose, someone was asking how we make it larger. Can you explain how you make the expression larger on the screen?
Oh yeah, sure. I just press and hold the control key and use the wheel on my mouse to make it bigger. So that's kind of handy. It's one of those hidden tricks that are not documented. I think I found it by chance, but it's I really like it. So so that's the very simple way. I mean, the simplest way that just takes an input and an output is like this. Or if I want to have two parameters, input 2, and then I select what type of data type is returning. Maybe I am adding 2 numbers. Well, I put it to real or 2 integers. It really depends. And then what type of function is going to be, if it's going to be a just custom function or aggregator. Is it going to aggregate all the numbers in one column, or is just one per node? We're going to see what nodes are in a minute. And finally, the category, where I want that function to rely here. Unfortunately, I cannot create new categories, but that's more than enough to have a category, and you can always search for them. And then here in the description, you put the description on what the function is, the example, the documentation, and what. So let's take a closer look at the camel case. I already explained how that works, but here is in action. So let me make this bigger, just in case you're not seeing it properly. So again, this is code, Python code using the stringer library, and then I created this custom function called proper. I could have called it proper case, but it's going to. This is internal function. I am for the external user or the end user. I'm calling it camel. Here's the documentation, and then here's how I call it. So I have the output, and then I'm calling my own function by passing this parameter. So the parameter is a string, and it's going to be the input or the first input parameter from the user. Any questions so far? Because before we go to the next slide,
there are a couple questions. One is about, does the output of the rank function change dynamically depending on whether data is marked or filtered?
Okay, this is a great question. So when you create calculated columns, it's not going to respond to the filters. But when you use a custom expression in your visualization, it's a little bit different, because on the visualization itself, you have to reference the axis that you are going to using for your calculation. That's going to react on your filters when you change that. So let's maybe look at this example. I mean, it's there is no custom expression here, but I'm using the data1 file. So let's go to my table. This one, if I change the numbers, yeah, it's not changing, but there should be a way to make it.
I think my guess would be that the show hide items might be something that could filter dynamically.
Oh, okay.
I'm thinking that, yeah, if it's just a calculated column, the rank is set, and that column has been created. So like when you do a marking or filtering, it's just gonna take out rows, but the same column will still stand. But I'm guessing that maybe something with like show or hide columns, since it can get the top 10 or something like that, and it can hide it. I'm hoping that maybe dynamically, if you click on something, that it can get rid of just the data that's been after filtered.
Yeah,
in this case, there's only 3.
Yeah, how that? Yeah. Well, here I have the colors. Well, the colors is the colors.
Oh, the
maybe
colors
change a little. The colors. Yeah, the colors kind of change when dynamically, but that's the concept. Anything else?
I believe there's one more about whether expression functions can sit on the server as well to just being in the document.
On the server?
Yeah, like one of those expressions that you made, yeah.
Okay, so you can use custom expressions on data on demand, and I believe I did that example with some data table that's coming from, let me see. Maybe this one. Oh, well, when you create a data table from an information link, when you get where you're getting data, you can use those transformations. You can use a custom expression to limit data with a data function. You have relations, or when you are limiting data on demand. Let's say you have a lot of data and you want to limit the data based on a document property. Let's say you are only interested in 1 month, so you can pass those parameters on. Let's look at this one, for example. When I bring that data table, I can do some settings. I can do the on-demand, and when I do my settings, I can say, okay, well, I want the report date. This one, yeah, the report creation date. I define my input, and I have an opportunity to use a range or values, and I can have a custom expression, and there is where I can make my custom expression to be valid. So I can.
Do you know though if like the Fahrenheit to Celsius expression function that you created can be accessible through here as well, or is it just limited to the DXP you're working on?
So if you want to limit the data using an expression on the data on demand, then you have to use, for example, let's look at some integer, and then I am going to value using custom expression. I use the custom expression, and then I can use the TERR function here, or for example, the case. It's still available. So when the data comes through, it's going to automatically perform that calculation with my camel case. I just pass the parameters that I need for that, and yeah, you'll have that ready to go on the on-demand, or when using a transformation on your data canvas. If I want to add a new transformation, I can do so. So add a transformation, transform data. Yeah, I can also have calculate and replace a column, or calculate a new column, and I can do my custom expression here, right here. Okay, well, let's move on so we can continue with what we're doing. So I am going to talk a little bit more about this before I pass it on to Adam, so he can explain more about this. So the node navigation, it's a feature in the Spotfire that allows users to create hierarchical structures in the data and navigate through them to gain deeper insights. It is a way of organizing and visualizing complex data structures, such as a multi-level categorization, hierarchies. It's making it easy to explore relationships between different levels of data. The node navigation works by creating a hierarchy of nodes, and each node is representing a level in the data structures. Users can then navigate through the hierarchy by selecting different nodes and drill down into sublevels to view more detailed data. That enables users to perform complex data analysis and identify patterns and relationships with different levels of data. Node navigation can be especially useful for working with large and complex data sets, such as customers in the financial data, where there are multiple levels of categorization and relationships between different data points. But maybe maybe it doesn't make sense anything I read, but I think it will become more meaningful when we go through the examples. So let's continue with some of these expressions with no navigation. Here we have the case statement, and Adam is going to give us an example on a real life dashboard that he created with these different expressions using the case, the over, the intersect, and even using document properties in expression. So from here, it's all yours, Adam.
Yep, sounds good. Sure. Cool. Are we seeing my screen?
Yeah, I can see it.
Cool. All right, so today what I want to show is basically just an example of a dashboard that I built. This is basically just an exploratory dashboard to learn a little bit about baseball teams and Major League Baseball and seeing who the best players in their team history is. It's just a fun little dashboard. I mean, you can like find it on my LinkedIn. I posted it there. But I figured that I could go in and I could show basically the use of custom expressions that I use basically all over the place in this dashboard. So to start, like this first page, what it allows you to do is just click on different teams and it will filter the data into just the teams I'm looking for. And then there's a nice little animated bubble chart showing the evolution of the best player, the top 10 best players in that franchise history over time. But essentially, the problem that I had in the beginning was not all of these images came out. So like there's a few of them where they didn't register and they ended up being blank and then it didn't look good. And the reason why is because the abbreviations for the team just were mixed up in the data set that I had and where I was getting these images from. So the easy way to like make a fix like this is to just create a new column, or you could create or calculate and replace the column. So if I just go into my data canvas and I look at the data table that I'm working with, you can use these case when statements to essentially just do like easy edits. So in this case, there were 3 teams that had problems. So for example, this first one it used to be ANA. That's
You wanna zoom in a little bit the expression?
Oh yeah, sure. Let's see. Control scroll. Yep, is that better?
Yeah, that's much better.
Awesome, great. So essentially what it used to be was ANA because they used to be the Anaheim Angels, but they then changed their name to the Los Angeles Angels of Anaheim. Very silly name, but they ended up changing it, and for me to make that simple change, all I need to do is this case when syntax. So it's case and then some sort of just expression here, some sort of Boolean where I'm saying when franchise is equal to ANA, then do this. So then make it LAA. When it's FLA, make it MIA, TBD, TBR. So after just each of these, and you can just do them consecutively. So case when, then, when, then, and then I have to put an else. So in this case, else, I just keep it the same. So else just use franchise ID and then do end. So that's the way that it's set up. And if you want to know about different syntax to do this too, I'm pretty sure that there are multiple ways that you could set up the syntax. If you just go on to that search on the top right and you look up case, there's a lot of really solid examples about different ways that you can do it. You might not be able to see it here, but just definitely reference that if you're looking to learn a little bit about the syntax, so you need a reminder.
Yes, and there's another way, because the expression is the same all along. There's a shortcut, and the example there is that you can just use case when and then the column, and that's it. You don't have to have any comparison. And then you do so is case the column name, case the column name, and then when when Anna, then LAA. When FLA,
then it looks like there could be something where it's case, the column name, and then when I don't have to do this equal sign again. I can just do when ANA, then.
Yeah, that's another way. That's another way.
Cool. So there's even many different ways. So that's a great example to reference this if you have any sort of interest in using the case expression. So yeah, just wanted to show you, that was a very simple way for me to create a new column. And now if I define, this visualization on the top by that new column, I don't have any sort of missing labels and all my images come out clearly. So that is just the first example that I have. Now, the next one that I want to show is on the next page. So the way that this works is that I am doing a deeper dive into the team that I selected on that first page. So this is looking at the Seattle Mariners, and this is showing basically like all of their players throughout their franchise history, showing me the best ones, the top 10 players as determined by a statistic called WAR, which is wins above replacement. It's basically how many wins a specific player contributed to their team. So the reason why I say that is that I am using that for this top right visualization. So this here is showing the players in franchise history who had over 10 WAR, which is like a solid baseline for that one team. And then the size here is by how many years that they played, and the colors, how much WAR they contributed. So the gold ones here are the top 10 players in that history. Now, the way that I get that data to be filtered is I'm going to use a limit by expression. So going into the properties, into data, I have limit data using an expression. And if I zoom this in, this is the way that the expression is working. So I'm asking for the sum over the intersection of the name and the franchise ID to be over 10. So on a separate page now, I'll just go a little bit deeper into how that works. So the original data that we have is set up in a way where it has every single player in Major League Baseball history with the year, the franchise that they played for, and the amount of WAR that they contributed. So players can play for multiple teams. They could have empty WAR because they never even played a game that season, things like that. So from this data, what's happening is when I call the intersect name, common, and franchise ID, it's acting sort of as like a group by in SQL, something like that. And it's basically pinning those two variables together as if they were one individual group. So I go from that original data, and then the intersection is going to be, I can represent it in this like cross table here. And what it is now it's showing me the name common, the franchise ID, and then the sum of the WAR for that team. So we see that this first player played for two different teams, and I want to add up those WARs separately. The next player we see played for a ton of different teams, and we want to add up their WAR just for the one individual team. So then if you bring the whole expression together, the sum of WAR over the intersection is greater than 10. So basically on that page, I do have a filter to only look at players, or to only look at franchise ID is equal to SEA, Seattle. So now it's going to show me basically the individual groupings where it's a name and then SEA and then the sum of WAR. And then I'm going to, what it does is I'm here sorting by it, but it's asking to only look at those who had over 10. And we see that the result is we have one player that's at 10.17, and then we have the best player in the franchise history at 70.55. And we could see here that without the expression, it is very, very messy. I mean, I think it kind of looks cool in a certain way, but it's not really entirely too readable. But after the expression, we see that there are a lot fewer players that show up, and it's a little bit easier on the last page to select them, things like that. So that is how this expression works, using over and basically doing this group by. So now on to my next page that I have here. This is essentially a way to go one step further and to dive deeper into one player's individual season. So I could click on anything from the last page, and I can get like basically like the baseball card of that player for the one season. Now, so the way that this works is I have like their statistics for the season. There are on the top 3 metrics that are basically like percentages. So right here we have BA, which is batting average. This is the amount of hits divided by the at bats. So there's going to be some sort of division that's happening here. So the on base percentage is similar. And OPS is also a metric that's kind of defined as a percentage of sorts. Then for these 9 stats below, these are our counting stats. So these are things that throughout the season you kind of cumulatively add on. So why I mention that is because on the bottom, what I'm looking at are 2 different charts. One on the left is showing me the evolution of the statistic over the season, but on the left side, it's the percentage statistic, and on the right side, it's one of these counting statistics. And where I'm using the custom expression is right here. So on the y-axis of each of these, what I'm doing is an if statement that's asking, basically doing the logic of, well, if I click on one of the statistics here, is it a counting statistic or a metric statistic? And if it's a metric, it's saying that make this y-axis what I've selected.
You want to zoom in?
Otherwise, keep it as the default. Yeah, I can zoom in, sorry. Here we go, is that better?
Yeah,
Let's
perfect.
see. Make it a
Perfect.
little bit bigger.
Yeah.
Okay, so, and what this is also is a good example of using, accessing document properties in both ways. So there's 2 ways to bring in a document property. You could either insert it as a value or insert it as text. And the difference between the 2 is that when you insert it as a document property, like in this case, we're looking at a string. So if I when I insert it as, a value, it's going to look like this document property with the quotes inside of it. And what this basically gets evaluated to is that actual document property and its value, but like in quotes here. So this first one, because I use it in that way, what the if statement will get evaluated to is if like quote BA equals quote BA, which is what I have. Now, if I insert it differently and insert it as a text, what it's going to do is it's going to evaluate the document property as if I actually just like wrote it in. So it's going to read it as just BA, but without the quotes. So these can be useful in different ways. So if I undo all this, the way that I'm doing it is first I want to ask, well, is the value actually equal to BA, which is my default? And if it is, keep this y-axis as BA. Otherwise, use the selected statistic. But in this case, I'm using the document property as a text because I want to access the column. So usually when accessing columns, I'm going to be inserting it as text because I'm going to use it like within brackets and then access the column that's defined by my document property. Whereas the other way, I use it to usually be able to like put it in expressions and have it as equal to certain values. And then like the final way too is that you can also insert it as text if you want to have the display name be the document property. So that's another way that you would, kind of act as if you were just writing something right then.
And also notice, before you cancel, Adam, notice that the
Mhm.
resulting expression and the just
Yep.
above that one, it will render that document property in the actual expression, so you can actually copy that, maybe paste it there, or put it
Yeah.
as
Let
a
me just
comment.
make it. So this is
And
what is looked at on the bottom right.
that's how it renders. And before you go on, I also want to share some of the ways I use document property in custom expressions. So let me share my screen real quick. And these are very useful custom expressions. For example, if you want to do a monthly report, last 30 days, this week, this month, year to date, here are the custom expressions that I'm going to share at the end of the video in the description. so you can have these custom expressions handy. That was just a quick parenthesis. You can share your screen, Adam, and continue.
Okay. Yeah, great. Cool. We seeing it?
Yes.
All right, cool. So yeah, that was just the result of basically, I wanted to show off, well, first how we could use document properties within a custom expression. I'll also show how this is actually working too. So if I click on the H here, this is one of the counting statistics. So we see that the chart on the right ended up changing. If I click on 2B, this will also change the one on the right. 3B, all this would change, but you'll notice the left isn't changing. But if I click on OBP here, what it's going to do is it changes the left chart, and then the right chart is left as its default again. I could change it to OPS and it'll do the same thing. So that's kind of just a neat way to be able to have like conditioning based on markings and stuff. And the way that I have that working is I'm using a data function to be able to gather the marking that I have, and I can have that trigger some IronPython. And I'll get into the setting up the expressions in IronPython just in a second. But first thing I want to show is, so you notice that there's this huge map here, and what this map is doing is it's basically showing the performance of this player at the different stadiums that he played in. So like I can click on the different sorts of statistics and then show me how well he did it for that one statistic. Now, the thing that I had trouble with here is defining the color scheme for this marker layer. So if I open this up and I open up individual season, I noticed that if I just have the colors set to like something like max, median, and min, what it's going to do is it's going to show me, it's going to color all of these dots here by how like his individual max, median, and min. But I don't necessarily want to show that on this expression, because if he is very good at every single stadium, I want to show that he's really good everywhere. I don't want to show how good he is in comparison to himself. I want to say, well, how good is he compared to the rest of the players in baseball? So what I did for this is I actually defined colors by a custom expression. So if you click on this pencil here, you can define a custom expression for one of these points on the color scheme. In this case, I'm doing just a very simple gathering of an expression. So for this, I'm having the red, meaning good here. I'm having the red as the color max document property. For the middle point, I'm taking the color median. And then for the bad, I'm taking this document property of a color min. And what I'm doing is I'm dynamically changing what those numbers are so that it also changes the color scheme here. So like this is the default color scheme, and it's like set as these three numbers. But when I click on a different statistic, there's different scales of what it means to be great, average, or bad for that statistic. So that's actually where I'm going to use some IronPython. So if I go into my file document properties, I have all these document properties that I find very helpful to use within my DXP. And I can trigger a script to occur when a certain document property changes. So that's basically the selection that I am selecting there on the left. And here, if I open this up, are you able to see this?
Yeah, you can zoom in a little the same way. There you go.
Awesome. So what I'm doing here is I'm basically asking, well, for the statistic that I've selected, give me like the first percentile, the median, the 50th percentile, and then the max being the 1. And the way that I'm actually doing it is you can define a custom expression using a string in IronPython. So that's what this line 5 is doing. It's like the same way that you type it out in a custom expression, except for like you have all of the dynamic inputs that I'm using in this script here. And if I actually run the script, the output might not be able to see it, but I'll paste it in here. The output are these three expressions. So this is what's being evaluated. So it's asking, this is the year that we're looking at for this Ken Griffey's season. And then I also want to ask for the statistic where the percentile is less than 0.01. So those are the expressions that get defined right here. I'm printing them out. But then you can use this dot select within IronPython when looking at a specific table. So I'm looking at this batting table. So I've had that as a parameter that goes into my script. But looking at this batting table, if you just do dot select and then put this custom expression, it'll limit the data similar to the way that the custom expression would anywhere else. So batting dot select, I've now limited my data, and then from that point, I use the rest of the logic to gather what the correct color should be. So I basically want to see what's the first percentile, or what's like the min of what the actual what this statistic is over all of the players. And then I want to make that to be very blue in my color scheme. And then the median I asked for, and then I want that to be white, and the max I want it to be red. So this is like a really neat way. So like this will be dynamic based on the selection that I make here. It'll go through three different numbers here to be evaluated in different custom expressions, and then that'll get stored in a different document property. And that's that document property that I access in that color scheme in this map. So I hope that wasn't too much, but I find it to be, very useful to often like use IronPython with custom expressions, with different sort of like conditionings using if else's and things like that.
Yeah, no, that was very good, Adam. And remember that the help is available at any time. You can just press F1 in the window that you are on, or search a specific function, and it's very comprehensive. The help from Spotfire, I recommend going through, because it doesn't only explain you what happens, but why, and a little bit of background also in theory, and why how things work and purpose. Is very well written, the help file. So I encourage everyone to take a look at that for further investigation. And I am also going to share a couple of links. One of the questions here is, will this DXP available for students? So I can tell you right now that if you go to, you don't have to stop sharing, Adam. Okay. I can just switch back and forth. So if I go to the interactive demos here at TIBCO, then you will see that one of these is the Pro Basketball Draft Analyzer. And there's also an article entry here that you can go through with a little bit more description about it. I don't know if you can download the DXP, but just let us know. And then we also have another question here from Steven. It says, he was just wondering, it's a great question, if when we create if TERR can process available function from Python libraries. I don't think you can call a Python library from R. So if you create a data function in R and you want to call it a Python, I don't think it's that possible. Or even when you create a custom function, I think custom expression functions are only available in R. Maybe in the future they will open up for Python. I'm not sure about that. But you can always ask ChatGPT to translate that R function into Python, or vice versa. It really works very well.
Yeah, I'd recommend that, or maybe even ask ChatGPT just if there is some sort of library in R that lets you execute Python. I mean, I don't know, but I bet you it would know.
Here's another question for you, Adam. Mr. Aliyev Agamedi, hope I pronounced it right. He says, can you let us know what mod you have used for this nice dashboard? Thank you. And it is possible to get embedded version of this DXP, which includes mods.
Yeah, so the mod that you're looking at here on this page is a rows chart. yeah, this rose chart I find very valuable to look at, like, yeah, different sorts of categorical variables, and then like in this case, looking at the percentiles of like how well this player did compared to everyone else. So if I open this up, you know, you could find this all in the Tipico community, but I believe I have it added in, yeah, the rose chart right there. So that's a really cool mod that I found very useful. It's not a mod, but I'll say that the waterfall chart I think works really well here. So like I realized that like with counting stats over time, this rose chart was pretty cool to show like, you know, like when Ken Griffey Jr. actually hit home runs, and it shows like basically this cool staircase of one counting statistic over a period of time. So I think that that's the one mod on this page. This is the animated, or not the animated, but the just, what is this called? A bubble chart, but circular tree map is what this one is called. Yeah, so this one is really great to just kind of show, I guess, just this series of players and be able to color them differently, make them larger and smaller. You can also add hierarchies into these circles here too. I think that that's another kind of way that it's like a bit like a tree map. But yeah, I usually like to be able to add one of these circular tree maps into my DXPs. And then let's see. And then the first one on this first page, we have the animated bubble chart. So this is one where you're able to see basically a bubble, you know, happening over time, over a period of time. So you specify to animate by over like a date period. So it's showing me all different years, and then I'm looking at basically like a kind of like a scatter plot, but it's, you know, dynamic and it's changing from date to date. And then finally on the right, what we're looking at is I believe it's the spider chart. Let's see. Yeah, it's the spider chart. Yeah, I thought that this was also a really cool way to be able to see this. So this is looking at, right, the entire history of the franchise, and it's looking at the total WAR of all the players. So I was saying that WAR was that one statistic to see how good an individual player was. But if you know, sum up the WAR over everyone on the team, you basically get like how good was that team. And we see like basically like the peaks and how good this franchise was. And I could like click on different franchises here, and you could see how like they might all be pretty different. So like there was a lot of success at this period of time, they got bad, and then they got good again, things like that. So that's a pretty neat way to use that spider chart as well. Then as far as like this dashboard, I posted it on my LinkedIn. I don't know if it's not on the demo gallery or anything. It was just something that I worked on, but there is a public link available to it that you could get, and you could like play around with it and like click through. Cool.
Okay, I got disconnected for a second, but I want to take this opportunity before we run out of time that there is a lot of mods available. You can explore all the available mods here in the tipco.com, and then you will see all these mods available. There are new mods available going every day. All you have to do is download and drag and drop the mod file to your analysis, and the mod can be embedded in your analysis, just like you do with any other file or data. You can embed it, or you can save the mod into your library for everyone to use. So here's the rows chart that Adam was talking about, and there are other more to check them out, interact with them. And if you're interested in learning how to create a existing mod, maybe there's a mod here where the source code is available through GitHub, then you can also check out the Spotfire mod developers hub. So it goes through the basic how to use mods, what are mods, all the way to how to create or modify existing mods. And that's it for now. I thank you for watching, and I hope you have a great rest of the week, and keep you in touch.
Yep, thank you.
Thank you, everyone. Bye-bye.
Bye-bye.